All right, so we're getting into one of the last sections of Unit 6, and this is 612, and solving problems involving ratios, specifically ratios, range, and unit range. And this is real world problems, and this is something I've done in the real world a lot, and solving ratios and rates in the real world is actually one of the real applicable things you'll do all the time, especially if you're trying to calculate costs or especially in business and stuff. So here's one I was faced with a lot uh, in some business type of stuff in the diving world when we were putting together trips, trying to figure out the most economical way to do dive trips for everybody because divers are cheap. We want to cram everybody into hotel rooms. We want to figure out the cheapest way to get places so that we have more time and money to spend on diving and dive gear. So we're planning a trip to Venice, Florida. Venice, Florida is 284 miles away. We want to dive for some shark's teeth, and we have two options. Um, Gas being 300 or $3.10 a gallon. We have six people going with us, and we can cram everybody in a van with six people. It's one of them big hulking vans that get just 10 miles a gallon, and will be all hot and crowded, but it holds all the gear strapped to the top and into the back, and maybe we'll pull a trailer with the two, and with all that together, it gets 10 miles a gallon. Another option is we throw it in the back of a pickup truck that seats two people. That when that happens, that truck gets 20 miles a gallon, and then everybody else squeezes into this little diesel Jetta that gets 40 miles a gallon. Um, or maybe it's not a diesel Jetta, then it would change the fuel cost. And it would make this more expensive. But they decided that we're all going to go in and split the cost evenly of the fuel. And the question is, what is going to be the cheapest option? So this is a lot of information to kind of to cram into one problem. Right? It's actually doing the problem twice with a couple different variables. So, so how do you do it? There's this really powerful thing called unit analysis. You can call it the railroad track method and all this other stuff. And you really don't need necessarily to remember a bunch of equations and conversion factors if you remember unit analysis. Well, I guess you remember conversion factors, but you don't have to remember a bunch of these equations. If I can remember, here, it's my straight edge. If you can remember this thing called the railroad track method. Right, so I'm given all this stuff here, and I know that what I'm trying to find at the end of the day is dollars per people, right? Dollars per people. So I'll figure out how much this option is going to cost. Option one. So I'll do option one first. This is option one. Now I'm running out of ink for that already. Option one. Option one first. Option one is first. So option one, I'm going to be using this information. Using that information. Now, before we start putting stuff into the railroad tracks, you have to figure out what information did they give you in bits and pieces that you need to actually use into. Okay? So this is a 284 miles to Venice, right? Well, 285 more miles is just one way. So we have to go there and back. So 284 miles is just the one way. So we got to go there twice. So it's 284 miles there and back, or it's not there and back. It's just one way. So it's 284 miles one way. So we got to multiply that by 2. So our total round trip is 568 miles. So it's 568 miles. 284 times 2 is 568 miles round trip. That's the actual value we're going to be using in our calculation. And then the total number of people we already have identified as 6 right here. Okay. So let's do the first one here. So our option 1. What are we? So we need to get at the end of the day, at the end of this calculation, our units need to be dollars per people, right? So what is the first thing we put on top? Well, first thing we put on top is the dollars per gallon, right? So I'm going to go ahead and put gasoline is $3.10. I'm going to start my railroad tracks. I'll do my railroad tracks in blue, I guess. I don't know how many railroad tracks I'm going to need. I'm just going to start doing that then. That's my railroad tracks. And this is just like kind of like a divisor sign. Okay. So this is the top of a equation. This is the top of a fraction up here. And this is the bottom of a fraction down here. Okay. So that's $310 or $3.10 per gallon. Okay, so that is my ratio, right? That's a ratio of dollars per gallon. $3.10 per 1 gallon. Per one gallon. Okay. And let's see, I know what other ratios do I know right here. I know that I can get 10 miles per gallon. So how am I going to arrange that here? Well, I need to arrange that so that it's going to cancel stuff out, right? So if I'm going to cancel stuff out, in order for it to cancel stuff out, the gallon is going to get canceled out. So it's going to be miles per gallon. If I did miles on top and gallons on the bottom, they wouldn't cancel out. So I have to put 10 miles per gallon. Okay, so if you're able to do that now, this is 10 miles per gallon, right? You can flip and flop it like that, and you do so in a manner which will make it cancel out. Like one on top, one on the bottom, they'll cancel out. Okay. So now I'm down to, now that I have those, I'm going to cancel those out. I'll use, now I'm down to, my units are dollars per mile. I have dollars per mile. Okay. And let's see, now I have, how many miles do I have to go? Well, I have 356 miles. How do I get the miles to go away? Well, what did I say? I have 568 miles. I have 568 miles. Well, if I need to get the miles to go away, do I put it on the top or the bottom? Well, I need to put it on the top to make the miles cancel out. So I go 568 miles. Now those miles will cancel out. 568 miles. Those miles now cancel out. Now my units are $310. So that's the total amount of dollars it's going to be. Right? So if I wanted to figure out how much money it's going to take me just to get there, it's going to be 310 divided by 10 times 568. That's how much fuel cost it's going to cost me, $176.08. Okay, but if I'm splitting it up about 6 people. I mean, in this vehicle, in the 10 mile per hour, in a 10 mile per gallon vehicle, it's going to cost me $176 round trip. Now, if I split that up about amongst 6 people, put that here. 6 people. Divide that by 6. That's now going to be about $29. $29 and 35 cents per person. Okay, so that's dollars per person, per people. Okay, so dollars per person. All right, so that's the power unit analysis. Now let's do option 2. Let's do option 2. And we kind of have to do it for 2 vehicles here. So option 2. We start with $310. Just like we did before, per 1 gallon. And then we have a vehicle that goes where is it? Here it goes. It gets 20 miles per gallon. And it's got to go 568 miles. And that's going to give us some amount of money. Miles, I forgot my miles. So let me make sure my unit analysis on that one's right. So gallons cancel out. That says miles per gallon. Oops. Miles per gallon. So now I'm just have money. That's how much money that one's going to cost. And then we're going to have to add that one to the other vehicle. And it's going to be 310. $3.10 per gallon. I don't know why they made that so big. And then this one cost this one does 40 miles per gallon. And it's still got, and it has to go 568 miles. Okay, and then so that's going to equal our total cost. All right, so let's do that. Let's get this to focus again. All right, so let's do this one. 310 divided by 20 times 568. This value here is 8804 $4. And this value here is 310 divided by 40 times 568 is 4402. Add those together. Equals 132.06, and then divide that by our 6 people. So 132.06. So 132.06 divided by 6 people equals $22.01 per person. All right, so you can see here that is actually more cost effective to ride in comfort in this scenario based upon the fuel economy of these two vehicles than it is to cram everybody uncomfortably in this gas guzzling vehicle here. So that is where you can see which one where it's pays to ride in luxury for this particular example. See, what was the total cost of this one again? I forgot to write it down. 310 divided by 1 times 10. Nope. 310 divided by 10. That's what it was. Equals times 568 equals times 6, or divided by 6 equals, that's not right. 3, I'm pushing buttons fast. 310 divided by 10 times 568. Yeah, it was $176. It was 176. Yeah, so it was 176.08 versus 132.06. And then, so what would it be? What does this value give us if we just did this and this? The 310, this is the miles, dollars per mile, right? 310 divided by 10, that's 31 cents a mile, right, for this one. 31 cents a mile, and if we did it over here, it's 310 divided by 20. That's, I'll do 16 cents a mile. And that's 310 divided by 40. That's 8 cents a mile plus 16 cents a mile is 23 cents, 24 cents a mile. So this was 31 cents a mile. 31 cents a mile versus 23 cents a mile, or 24 cents a mile, right? So dollars per mile. This is dollars per mile for the total of these. So you can see it even after one single calculation, which one's going to be more cost effective. But those cents per mile pay off in the long run. So anyway, I hope that was helpful in a couple of reasons. Setting up this unit analysis and this train track method. If you know what units you have to work with, you know what units you need to have when you're done, and just knowing how to flip and flop the units and the associated constants with the units. It's a very powerful tool, right? And that's why, like, if you're working in physics or something, knowing what a joule is, or knowing the units for work, and stuff like that, make memorizing equations the way of the dinosaur. So, anyway, I hope that helps out a lot. You guys have a great day.